Hi, I'm Krista Campbell. Welcome to the last webinar in our Field Operations webinar series. We hope that you enjoyed the first two webinars, Improving Inspections and Maintenance and Optimizing Capital Work. In today's webinar, Advanced Technologies, we will share how technological advancements continue to improve operational workflows. This webinar is being recorded and will be available to watch again and to share with your colleagues. Please enter your questions in the questions dialog box. You can enter questions anytime during the webinar. We will answer questions at the end as time permits. Questions that we do not get to will be answered in a Q&A document that will be shared on GeoNet. Please welcome back Pat Hull, Director on Esri's electric team. Solution engineers joining us today are Ben Siegel from Esri's water team and Michael Deniger from the utilities and telecom teams. Our agenda today includes a technology overview by Pat, and then Ben and Mike will share quick demonstrations focused on productivity tools, including barcode scanning and voice-to-text, using imagery to support daily work, leveraging artificial intelligence, and a few benefits of visualizing assets in 3D. Pat, let's go ahead and get started.
Thanks, Krista, and thank you all for spending a few minutes of your day with us today. This is the last of the three-part series on field operations. Part 1 covered ways to improve planned inspection and maintenance work. And in Part 2, we looked at larger capital work projects. If you missed those, please use the links to go back and reference them. Today, let's look at where the industry is going, using advanced technology to make field work better. Technology has made so many things in our world easier, and field work is no exception. Most organizations already use GIS for tracking and mapping infrastructure, but the way it's being used has changed, and it's grown. GIS now incorporates many advancements like those you see here on the screen. They help fieldwork in some surprising ways. These tools present new kinds of information, and they help find what's important, and then they let you see it in new ways. We have a lot to show you about safer, faster, and easier ways to work in the field that uses these different technologies. We'll start by looking at some of the ways to help a user be more productive with less typing. We want to give you an overview of the modern features available to make apps more user-friendly. Although it sounds futuristic, artificial intelligence, or AI, is real right now. AI is good at the grunt work of figuring out what's important, especially in images, saving hours and hours of staff time looking at pictures that don't matter. Many agencies I talk to want to use imagery and drones, but it hasn't always been easy. We'll see that the state of the art to make use of imagery and drones is straightforward, allowing you to leverage new tools, manage all of the images, and focus on what's important, your infrastructure. We'll end with a look at where things are and where they're going in 3D and what visualization means to field work. Now, clicking and typing are not great field activities, particularly when you're wearing gloves or you're out in the bright sunlight. Productive field tools leverage the worker's skill and knowledge, and they minimize repetitive tasks. ArcGIS tools work together with many built-in features to improve usability for staff. How could staff avoid a lot of typing? With voice commands and voice recognition. How can tools remain aware of the user's context? By using barcode scanning to identify equipment and locations, smart tools know what you're working on without typing. How can staff be kept aware in real time? By using information and alerts that are based on location, smart tools know right where you are, what's near you, and then help the user. So whether you're patrolling a line, entering a protected habitat, in a flood zone, or near a gas leak, those things can all help you. Ben, I know you could spend a lot of time here, but would you take just a few minutes to give us a sampling of the kind of productivity aids that are there to help with field work?
Thanks, Pat. I'd be happy to. So imagine I'm a field worker for a water utility, and I've been assigned to inspect a pump station. I'll use Tracker to track my progress as I navigate to the pump station. Tracker can be used to see where field workers are located throughout a service area and track where they have spent time. Here we can see a dashboard with tracker footprints that have crossed through a hazardous area. Management or dispatch could use an application like this to see if field workers are entering areas deemed dangerous. On the map, the red polygon indicates that there is a warning or danger in the area. As I drive through the polygon, an automatic alert is sent to my mobile device telling me to be aware of a dangerous customer. This is done using geofencing technology through GeoEvent. We've configured GeoEvent to automatically send out a text alert anytime a field worker's tracks cross through the hazardous area. On my mobile device, we can see I just received an alert that says, "Beware of dangerous customer, Michael B." If I'm in the car, I can even use a mobile device assistant like Siri to read off my last text. We can use this technology to alert field workers about almost anything, not just angry customers. For example, we might want to let a field worker know if they're entering an environmentally protected area or an area with an endangered animal species. Now that I've successfully navigated through all the hazards and reached my inspection area, I can begin to use my mobile device to capture information. Using the camera, I can scan a QR code attached to the pump station, which will prompt a link to open an inspection form. We can see that by scanning the code, some of the fields are pre-populated, like the facility ID and the address. This means less typing and more accurate data. I'll then fill out the form, so I'll put my name down for the inspector. I'll add a pressure and a rate. And I can even fill out some notes. Maybe there's a component that needs to be replaced. I'll use talk to text to fill out that information. Replace rusty valve. Once submitted, those back in the office can see the current status of this pump station and any future work that might need to be done. So those are just a couple examples of some easy to use advanced technologies that can increase productivity for field workers. So I'll send it back to you, Pat.
Thanks, Ben. Most of the craft workers that I know do not like to type. So I really appreciate that we're using the latest aids to make those apps more usable, like voice recognition that people use when they're texting on their phones every day. And barcoding has become very prevalent in several of these industries for tracking and traceability. So that fits right in with common workflows. And then getting alerts about what's happening around you is like having a personal assistant. Now, I think that's perfect. We hear a lot about artificial intelligence. It's already being used in places like online photo services where many people realize that they are using it routinely. New computing capabilities find patterns and identify important features, allowing staff to focus their expertise where it's needed most. As an example, let's look at the capabilities built right into ArcGIS to find things that the field cares about. You'll see how these advanced technologies can be used within normal work. Watch for how workers can easily find what's important and how they can plan ahead for field conditions. Michael, you're going to show us how AI can find the things that we care about in imagery. Can you walk us through how this could help a crew heading out for a routine patrol inspection?
Of course. So today I'm going to show you how we can look at some artificial intelligence processes that will make our jobs significantly easier. To start with, we can look at some of the artificial intelligence processes that are already baked into the ArcGIS Pro system. For this demonstration, we're going to be looking at a pipeline that a gas utility owns. As per government regulations, the utility must do annual checks on this property and the pipeline with the easement around it to make sure that there are no new structures, waste dumps, homeless encampments, road damage, or anything else that might make it difficult to do maintenance on that pipeline, as well as keep the safety concerns of the individuals in this area in mind. This includes making sure that we can access this pipeline and do any maintenance necessary. Currently, it is very difficult for an organization to plan this process as they have a lot of land they need to monitor, and the field workers are required to drive the roads, the organization needs to check permits, or they need to have multiple GIS analysts scour images for the desired items. To ease that workload, we can create a simple artificial intelligence process with some aerial photography that was taken of the pipeline area. In this map, you can see that we have a pipeline going through a rural area. The utility company needs to make sure that where the new structures exist. Instead of looking for every single structure, we can highlight the locations we care about most. You can see that we have highlighted these structures in green so that we know what we are looking for. To create a layer like this, an analyst really needs to just work for about an hour or even less if they have enough training. Once we feel that we have created a sufficient sample of the images that we are looking for, the buildings or other items, we are able to run the image classification geoprocessing tool that is in ArcGIS Pro out of the box. For the sake of time, we have that right here. As you can see, the image classification found quite a few more structures that we care about. This process has saved the utility hundreds of hours to identify all of these structures within this image. As this is an AI model, it can be used year after year in the maintenance of this pipeline. However, as we are concerned about these structures, not all of them are exactly what we need to look at for the specific process. And to make sure that our field workers are not wasting their time looking at structures that are not within the easement, we can create a simple easement line on our map. So this easement covers several miles around the pipeline, and we can see that there are some new structures within that area that the utility needs to be concerned about. Though the utility needs to make sure that they are only visiting structures that are important, we will do a simple selection and only get the structures that are within that easement. We now have the exact locations of the structures that our field workers need to visit to verify that the pipeline and those in the area are safe and easy to access for maintenance. Now, this artificial intelligence tool can be applied to a multitude of different processes, whether you are looking for structures or, as earlier stated, waste dumps, homeless encampments. We can also train this to look for damage on assets and a multitude of other things. You can use image classification processes to eliminate wasted time on scouring images and having your field workers drive through miles of empty road to find something that could have easily been found within ArcGIS Pro and its AI processes. Back to you, Pat.
Thanks, Michael. So AI finds and helps us focus on what's most important to improve our normal work. It can be used to find other things too: tree clearances, broken hardware, corrosion, even wood rot, all kinds of things that are observable in different forms of imagery from satellites, aircraft, or drones. But that's what we're going to talk about next, is imagery. Many agencies are using imagery to great advantage for their fieldwork. I've talked to customers hiring contractors to do this, and those with employees using their own personal drones to go out and look at suspect poles from above where access is very difficult. Many field organizations want to develop more in-house capability in this area, and ArcGIS has some great tools that tie right into the organization's existing facility map data. Imagery from satellites, aircraft, or drones shows conditions where access is difficult, time-consuming, or presents safety concerns. As we saw a moment ago, this is a great place to leverage artificial intelligence to inspect tall infrastructure safely and to examine equipment without taking it out of service. Michael, Esri has a full set of tools for imagery. Can you show us how they can be used for fieldwork?
Of course, I'd be happy to. Next, we're going to look at how we can apply those artificial intelligence processes that we have just looked at and really take our fieldwork up to that next level. In this example, we're an electric utility that maintains towers throughout Southern California. As we are concerned about our infrastructure, we also need to be aware of the natural environment in which our assets live. We need to make sure that our structures are not impacting wildlife in a negative way. One of the things we need to look for is nests for rare raptors that exist within our area. To help with this, we have introduced a drone collection process that can cut down time and increase safety. This red polygon represents the high flyover aerial photography that we had a drone do to look for potential nests within our electrical towers. As we were running this, we wanted our artificial intelligence to look specifically at the towers, as we're not looking for nests that exist in trees or bushes or any other location. So our artificial intelligence identified 4 towers within this range. Upon further investigation from that artificial intelligence, we found that 3 of them have nests in them. From this knowledge, we are able to create a workflow so that we can send our workers out to go out and investigate these towers, to look at these nests, to see what our next steps should be. Now with this, we can send any drone team that we have onto the site to look at this. And once our field worker has reached the site for the tower, they can easily use our mobile drone collection software to quickly set up a flight plan to investigate this structure. As you can see, the mobile application allows our field worker to select flights that have existed before, if this is a structure that we have investigated before, or create a new flight path depending on the need at that moment. Once our field worker has selected the type of path they want to use, they will be able to edit that on their iPad down to the exact formation that they want that drone to fly. Once that has been done, the application will give you a simple 3D image of what the flight path will look like and the estimate of how the structure will exist within that. This also tells us how many photos will be taken of this process. So we can see exactly how much work will need to be done even before we send out that drone to take the images. Once the drone has flown the path and has returned to the field worker, they can transfer the image via Bluetooth or an SD card to the iPad for further investigation. Once that imagery has been uploaded to the iPad, you can simply use our mobile drone collection software to see that all of these images have automatically been stitched together to create this map. Now, what we want to do now is we want to do further investigation on this map in a 3D scene. So once again, these are all images that were taken from any regular drone that can take images, and it automatically stitched them together to create this 3D image. We can even see our field worker's car here on the road. As we look at this, we know that our nest is in this location from earlier artificial intelligence processes. Now, on the right, you can see that it automatically populates all of the images that have that location inside of them. So what we want to do is we want to look for an image that has a good angle on that nest so we can potentially see what is inside of it. So if we select a random image, we will be able to see that that nest exists within this tower. This picture might not be exactly what we're looking for, as there is a pole that interferes with our line of sight. And let's go find something that allows us to actually see what's going on inside of that nest. We'll be able to see an image of that nest, and inside we can see that there are no eggs and there is no bird in it at the moment. From here, we can take those images and send them back to our management or environmental team so that we can take the steps to actually look into what needs to be done with it, whether we need to assign a field worker to remove that nest or talk with an environmental team to make sure that it is as protected as possible. One thing that our management team might want to know, for example, is how close that nest exists to our power lines. So what we can do is we can simply do a distance check and see that that nest is 24 feet away from our power line. So when we are assigning a work order for someone to remove this nest, we know the safety precautions that need to be taken to protect that field worker. Once again, all of this information can easily be shared back to our management team or the environmental team through organizational resources. With this process, we do not need to send field workers up the tower with risky equipment or have analysts sift through hundreds of images just to identify where this nest may be. We can simply have a drone operator team go to the location, easily set up a flight path, and do on-the-spot analysis of the desired information. Thank you. Back to you, Pat.
Michael, thank you. That's fantastic. One thing that really jumps out at me is how a drone inspection could be done with a much smaller crew and without taking this critical line out of service. It's a great way to see things from a perspective that you can't get from the ground. And when you can make work easier and safer, that is a win for field. When I was at the utility, we sometimes called the younger workforce digital natives because they grew up with computers and many of us did not. The digital natives, they expect companies to have the latest technology. They expect to be able to see things in 3D, like Michael just showed. 3D visualization improves understanding of field conditions in the real world. It helps answer some vital questions. How can job planning be improved for the actual site layout? How can staff conduct familiarization training away from the hazards? And how can safety be addressed before arriving on site? Ben, I think you've saved the best for last. Can you show us an example of how 3D relates to fieldwork?
As a digital native, this is something I'm really excited about. So first, I want to show you guys a 2D map. Field crews and office staff are probably used to seeing maps like this. This has become the new normal for utilities, where they can display and interact with their data in a 2D environment. However, 2D visualization has its limitations. Vertical features that connect underground pipes to above ground assets are impossible to visualize in 2D space. Point features stacked on top of each other need to be offset when using 2D visualization. And complex facilities like treatment plants and pump stations are difficult to model accurately and realistically. 3D maps and visualization can help bring utilities data to the next level by providing a more detailed and visually accurate view of their assets. By utilizing 3D visualization, field crews can have a better understanding of what features are in their system, how those features look in real life, and where those features are located. So here we have a 3D map of a water system that was created in ArcGIS Scene Viewer. From this angle, the map appears to be featureless. This is because most assets in a water utility are below ground. As we move our view below the surface, we are then able to see where these underground utility assets are located. We can see water mains, as well as lateral and vertical pipes. From this angle, we can also see features above ground, such as hydrants and building footprints. When creating 3D maps in Scene Viewer, there are two avenues available. First is to use the 3D environment in ArcGIS Pro to generate 3D features. There's even a solution for water, wastewater, and sewer that can help with this. The second option is to utilize attribute and geometric information in your 2D data sources, and then using symbolization options in Scene Viewer. For the scene I'm showing here, we're utilizing the second option. This means that all of these utility assets are referencing the exact same data that I showed in the 2D map. Field workers can use an application like this to explore their data, as well as run analysis for project planning in ways that they are unable to do using 2D maps. Using the user-friendly exploration tools, we can navigate through the below-ground environment and see where features are located and what they look like. Measurement tools can also be utilized to measure distance and area in 3D. For example, we can see that this building right here does not have a service connection. A field worker can use the distance measuring tool to measure the distance between the connection and the main and determine how much pipe they will need to install, and from there, how much it will cost. In order to get data into the state, there are a couple steps utilities can take. First is getting accurate location data. When mapping in 2D, we are usually just concerned with X and Y location information. But when using 3D, it's important to understand how far above or below ground an asset is. As JJ mentioned in last week's webinar, high accuracy GPS devices can be used to generate as-built data. As you collect data and your attribute information improves, that information can then be used to create 3D visualizations of your assets. Information such as elevation and distance below or above ground can then be used to visualize where features are positioned in 3D space. It's also important for utilities to have accurate attribute information about their infrastructure. We can use information like diameter to visualize pipe girth. So here we can see a couple different pipe diameter types, as well as how they connect. We can also use out-of-the-box shapes to accurately display features like hydrants. Here we can see a hydrant visualized using symbolization that is included in Scene Viewer. If this hydrant layer contained multiple types of assets, then we could visualize the features differently using an asset type field. 3D visualization can also be used for more complex modeling. Here we have a video of a detailed 3D water treatment facility. 3D facility models can be used for safety training and inspection or repair workflows. In the case of a water treatment facility, knowing where exits and safety features are before actually entering the facility can help with responding faster to issues like a chemical spill or a pipe burst. Using this model can tell you exactly which exits to use, where alarm systems are, and which valves might need to be shut off. Facilities are often densely packed with assets, so knowing exactly where an asset is within a structure and what it looks like can be immensely valuable when performing an inspection or repair. And as data and technology improves, 3D models can eventually be integrated with indoor mapping, so workers can see exactly where they are located within a treatment plant or utility facility. So that's all I have to show for 3D, but I'll let you take it from here, Pat.
Excellent, thanks, Ben. I think it's important to realize that ArcGIS is fully integrated with 3D visualizations from all kinds of data, from almost any source, whether that's from the CAD design and engineering, from actual field inspections, or collected as-built points that were captured at the time of installation. It has applications for augmented reality, and this is where Fieldwork is headed. Well, let's summarize. ArcGIS has productivity tools that make apps user-friendly for field users, making their work better. Artificial intelligence has reached a place where tools are built in and able to help staff find and focus on what is most important. A great place to apply artificial intelligence is in evaluating imagery that comes from satellites or drones to make inspections better in many cases, and everything is moving to 3D. It's built into ArcGIS along with the tools to work with your existing map infrastructure information. I'll close by saying thank you for joining us in this series. We have really enjoyed presenting these capabilities, and we trust that you found it valuable. We always welcome your feedback, and please feel free to reach out to us if we can be of help. Krista, what are your closing thoughts?
I'd also like to thank everyone for joining today. And if you would like to revisit content shared in today's webinar or the first two webinars, including the PowerPoint presentations, recording of the webinars, as well as the questions and answers document, these can all be found in GeoNet. The URL shared on the screen here will take you to the folder where all the content is stored. The URL is also in the chat window. If you'd like to just click on that, you should be able to directly go to our GeoNet site. Today's webinar recording and the questions from today will be added within a week or two. I would also like to remind attendees that the user conference is just around the corner. This year's UC will be a virtual event. One of the benefits of hosting a virtual user conference is that all customers who are current on licensing are able to attend for free. This includes all of the staff at your organization, not just the GIS staff. The utilities, telecom, and water teams will be creating industry-specific flyers that highlight UC sessions that you might be interested in. So stay connected with us on social to get updates and announcements concerning the Esri UC, as well as other industry events and activities. We look forward to connecting with you. Have a great day.